Hi everyone, welcome to the VMD tutorials. Today we'll continue the process of the automation of the data analysis in VMD. In the previous video, we wrote a script that will load the trajectory and the protein structure file, and then it will wrap the protein in the center of the simulation cell to avoid any interactions due to the periodic boundary conditions, which was an optional step. And then it was aligning the trajectory to the first frame, and then we do our selection, and then we calculated the RMSD of our protein. So today let's move a little bit further to extend this script to include two more analyses. So today we added the RMSF calculation for the protein backbone, which is an indication of the flexibility of your protein. So the higher RMSF, the more flexible is your protein. And we will try to find the salt bridges in our protein and track the evolution of the salt bridges throughout the trajectory. So as we used to do, let's go over what I wrote line by line to learn together. So before I go for RMSF calculation, we had to modify the script a little bit here, because when we asked VMD to get the number of frames, we said set number of steps. We created a variable called number of steps, mol info, get the number of frames. And then there's a tricky point here, is the trajectory starts from frame 0. So our VMD was showing us that we have 75 frames, if you remember. Let me open VMD so you can get what I'm saying. So we had the sample trajectory here. It was 75 frames, but actually we have 74 plus 0 frames, so it has 75. So for the RMSD analysis, it wouldn't be a problem for VMD. It would recognize that it will not put any value in the output file in front of the 0th frame, because it is the reference, and it will start adding the data from frame number 1, because we will have 74 output of the RMSD. But in RMSF, VMD would get confused. So I had to fix it. I could have fixed it here without telling you, but I want to keep the evolution as we are going, so I had to fix it like this. I will create a new variable called num, and I will ask VMD to calculate the number of steps minus 1. So because we have 0 at the beginning, so minus 1, we will have the 74 frames, and VMD will not get confused. Okay, and then we will set an out file, and we will call it rmsf.dat in the reading and in writing mode. And then I set the RMSF of the protein backbone, so our select will be name C alpha, because let's make it, because we have a solvent, but actually protein and name C alpha, but we have only C alphas in proteins, but anyway. And then we will create a variable called RMSF, and we will measure the RMSF for our selections, which is protein and name C alpha, which is the backbone, for the first frame, and the last is num, which is the number of frames minus 1, which is 74th frame, and the step is 1 for our stride. And also you could get rid of all of this if you have only a small script for RMSF, and what you could do is just say first 0 and last 74 or whatever. And you would recognize the problem. VMD would say selection is out of range. Okay, but you got the point what I did here. And then we will loop throughout the trajectory as we used to do in the RMSD here. We will say set I equals 0, and if I is less than the number of steps or frames we have, increase by I, and put our values into an output file, which is the out file that we assigned here. Where is the out assigned here? And then we will put the RMSF and the index. And also we did some expression in Tcl. It performed mathematical operation and give you the results. What I did here is I plus 1. Do you know why we did this? I will give you 30 seconds to think. Remember from our previous videos, we had the output file of RMSF is the residue number, and the RMSF, the corresponding RMSF. And since no PDB would start with 0, it would start with 1. So we will start with 1, and then we'll continue indexing the RMSF, because we start from the first residue, not from the 0 residue. That's the opposite for the frame. And then we will close, and then we have out file. So it's simple. We already aligned our structure. We will just calculate the RMSF. And then the second analysis I added, or the third analysis for the whole script, would be the salt bridges. We will try to find the salt bridges. In VMD, you know how VMD finds a salt bridge? It searches for the carbon and nitrogen of the basic and acidic residues, and by default, if the distance between these two atoms is 3.2 angstrom, it will be a salt bridge, and it will track the distance between this center of mass of this carbon and center of mass of this sorry, not carbon, I mean oxygen and nitrogen. So again, I may confuse you. So VMD, first to say this is a salt bridge, it will try if the distance by default between this oxygen and nitrogen is 3.2 angstrom. You cannot change this, I will tell you later. And if it's a salt bridge, it will track it through the trajectory and will give you the distance between these two atoms, I mean oxygen and nitrogen, the center of mass of oxygen to the center of mass of nitrogen, and you can plot it and see how your salt bridge is changing throughout the trajectory. Okay, so this is how the VMD salt bridge plugins work. So we will ask VMD to make a folder directory, because we will have many salt bridges, and we will say make their salt bridges, and then we will say package require salt bridge, and then here's the option of your salt bridge analysis. Cell is the atom select top protein, is my selection, which is for protein. Log, if you use this file, this option, it will create a file called saltbridge.log, and this is very important. It will tell you the options you assigned for your salt bridge analysis, because you may forget. You may set the cutoff distance between the oxygen and nitrogen to not to 3.2, but it was 3.7, and 3 months later you want to know how did you calculate it. So it will be very informative, because it will contain all the information we will see in a minute now. And my out directory, it will be a subdirectory of my current directory, and I call it salt bridge. And there are extra options for salt bridge analysis, which is update selections or frames. By default, it's all frames, but we could start, say, from 0 to 25 with the stride one. So it depends on how much you calculate, but by default, it will go for the whole trajectory. And ON distance, this was the cutoff distance I was talking about between the oxygen and nitrogen, and it is by default, as I said, 3.2, but you can just, what you could change, I'll just show you. You can just write like this and write 3.2. It was 3.5 or whatever. Okay, so this will depend on what you are doing. And COM distance is center of mass distance. By default, is not assigned, but you can also define it. And this is quite confusing. I don't know why VMD gives us the center as an output file. It gives you the frame and the corresponding center of mass between the oxygen and nitrogen, not the distance, this one. We need to search for it, but this is the available analysis in the plugin. And of course, we write files and out directory. By default, it's current, but as I told you, because it will create many files, many text files, I assign the subdirectory. And log is the file name that we were talking about, okay? So, to sum up everything from the beginning, we had 2 lines to load the trajectory and PSF file, to wrap it then to avoid any errors from the PPC conditions. And then we choose the selection to be aligned to the first frame, and we align, and then we get the number of steps and the for loops, and then the RMSD. I don't want to repeat it again, but I will focus here. We fixed this problem, and then we calculated the RMSF for protein and MC alpha, and start from the 0 frame and to the last frame with a stride one, and then we have for loop to iterate through the trajectory, and we closed, and then we get the salt pages and make a directory and get the package and set the options, and here are the extra options. I'm talking too much. Okay, so let's save what we have done here and call it auto.tcl, and let's try to do it. I'll go to VMD, extensions, let's source our script. Yes, and I will hit enter. Now it is grabbing and aligning and do the stuff, and it will take a while, and it is done. Don't worry for this is just some visualization issue, you know. And I have here first RMSD. Okay, let's reload it. Yeah, the RMSD, the step or the frame, and the RMSD, and this is what I was talking about. By default, VMD will not write any value here, so it starts writing from 1, so no need to tell VMD to remove the last frame, the last number. Okay, and then we're gonna have the RMSF residue number. I have here 388 as far as I remember for this protein. Yes, and you have the corresponding fluctuation or flexibility of your backbone, and then you can understand what is going on in your protein. Okay, and here the salt bridges directory, and you have here a lot of salt bridges. I mean, in real time you wouldn't search for the whole salt bridges in your structure. You may know that there's a salt bridge that controls something in your structure, and you want to track if the salt bridge is affected in your simulation condition or not, so you track it. But for the sake of tutorial, I found all the salt bridges. Okay, so this is the frame number, and this is the center of mass distance between the oxygen and the nitrogen of basic and the acidic residue that's forming this salt bridge. Cool. And what is important is this log file we were talking about. This is very important, which is it tells you what you have done and when. I did it just today, 20th of October 2020, and it says that I used from the first frame, which is 0 frame, to the last frame, 74, and the frame step is 1, and the cutoff distance was 3.2, and I didn't set any COM distance, it was none. And to write a file, and here we can have a nice summary of your salt bridges. Okay, so you can get a nice informations about what you have done, and if you set this to 3.5, you'll find that in log file. So I would recommend you to always assign a log file for the salt bridge analysis. Yeah, cool. So this is for today. Where is my auto file? Anyway, let me close some of them to appear. I mean, I closed it anyway. It was here. So here we have, very cool, we had RMSD, RMSF, and SESA, and I will continue adding radius of gyration and a lot of stuff, whatever we can do, so that at the end we're gonna have a long script that does everything for us. Okay, so if you have any questions or any comments, write in the comments, and sorry if I'm not responding as soon as possible for the comments, because sometimes I don't see them, sometimes I'm busy, and I will try this time. I used to say for you to send your email so that I can send you the scripts, because YouTube doesn't allow me to paste this stuff into the description. So this time I'll try to make something different. I will try to upload this script into a Google document, and then I will put it in the video description. And if you don't find it, just also write a comment, ask for the script, and I will send it to you. But I will do it also as soon as possible. Thank you, and if you have any suggestions for the channel, topics you want to learn, or if you want to teach something, just contact me and I will host you, so we can post the potential of the channel and we can learn together. That's for today, and see you.